Today we're going to learn how to use a breadboard. Okay, now for this segment, learning how to use a breadboard, first of all let's look at two different types of boards. First of all we have the Vero board. I'll just zoom in a fraction. Now the Vero board, as you can see, is a piece of, I think they call it phenolic board with many holes drilled through it. Okay, that's one side of the Vero board. The holes are for component legs to go through. I'll just zoom back out again and turn it round. The light may play up with the camera here, but let's give it a go anyway. Now if I zoom in again on the other side of the phenolic Vero board, what we see is many rows of copper tracks running from left to right. Each row is one hole. Here we go. So all the rows run from left to right and they are connected via a copper track. This is the sort of board that we use once we have created a circuit and we are sure that all the parameters and basically the timings, the parameters, everything that we have within that circuit is correct. It's working as we want it. Then we put it down onto a piece of Vero board. When we join the legs via the copper tracks, sometimes we will need to cut a track to cut between two holes, say, because they're not joined in the circuit. So what I generally use is a 3mm drill bit, and I stick it in the back side of the circuit and just turn it a few times, which cuts the copper track around the hole, thereby isolating, say, the left side of the track from the right side of the track. And yeah, basically that's how you build a circuit on the Vero board. But as I said, it is after you have worked out all the timing, the parameters, everything that is involved in that circuit is working correctly. Now we'll go one step further. This here is a breadboard. Now a breadboard is used for designing the circuit itself, working out all of the different timings, making sure that the circuit is operating within its parameters. As can be seen, I'll just try and get the best shot available. Okay, as can be seen, we have a row running along the top and another row underneath that. Okay, they are separated by gaps. See the gaps? Ah, that's perfect. Okay, so I'll just gear back there a bit. Now, so row running along the top here has a gap right there. Okay, right there. The row underneath it also has a gap right there, and they have gaps along the way. Now these rows, the top rows, are connected horizontally from left to right, except where the gaps exist. So if you wanted, say, this row to connect with this row, you would put a metal link in from this point here to this point here. That goes for all of the other rows on that horizontal line. If you need them to connect up, you connect a copper pin or a copper link between the points. Okay, between the points left to right. Where there's a solid gap, you need to link across that gap. So we have horizontal rows on the top, and then On the bottom of the board, the same thing, horizontal rows. Now I must explain that I've actually got two boards here connected one on top of the other. Okay, here's the first board, and then here's the second board. I like a lot of board to work with. I find that I can be lazy in my design to begin with, and when I get enough space, when I work out that everything's working on that board, then I start making it nice and tight, nice and clean, if you like. Anyway, look, I'll pan back in and we'll just concentrate on one of the segments. So we'll just go back up to here to the top segment. Okay, now, as I was saying, we have the horizontal lines going across the bottom and the horizontal lines going across the top, which if we all want them to be the same line, then we need to put a link across these solid gaps. We have to link them. Okay, now in the middle we have rows running down. You can kick the camera. We have rows running down which are actually numbered, going from 1 on this side right the way across the other side to 64. So we have these rows that run down vertically. Now there's 5 holes to a row and they all connect together. We do not need to link them, those 5 there. But if I wanted to link this 5 to this 5, I would need to put a link between here and here across the gap. Again, a little bit of wire with the insulation stripped off will make a perfect link. I like to use a pair of pliers and make them square, make them look neat, you know. It's good to have neat presentation. So this enables us to just plug components into these holes. So if a timing wasn't correct, say a resistor capacitor circuit, the timing was not quite what I wanted, I could pull the capacitor out and I could replace another capacitor in and then check the timing and go, yep, that's what I like. Oh no, it's not quite right. So I'll pull out another cap and replace the capacitor that's in there and just fiddle around with the circuit until we actually get it right. These center lines here, these center spaces, if you like, are perfect for integrated circuits or chips to be placed across. Okay, they fit beautifully. One set of legs on this side, one set of legs on this side, plug them in, and then you have access via these other 4 pins to that pin of the IC. Very, very handy a breadboard, integrated circuit breadboard. So the idea is generally to build your circuit on the breadboard, turn out a little bit, build your circuit on the breadboard, get everything correct, make sure that it works within the parameters, make sure all the timing is correct, everything that you want to happen happens when it happens, and then once you have perfected that, then place it onto a Vero board for permanent keeping. Because you know the circuit works, put it on your Vero board. If it doesn't work once you've got it on the Vero board, you know you've made a stuff up on the Vero board itself. Maybe you haven't isolated one side of a track from the other side, you haven't cut a gap where it should be. But yeah, basically you keep your circuit on here until you've finished building another circuit on here, because then if the one on the Vero board doesn't work correct, you can check the timings and the same points with the one that you've already built on the breadboard and check where you've gone wrong. We have handy little terminals for the breadboard also. I'll just pan in there, zoom in there. We have, here you can't quite see it, but we've got an earth pin. Then we have a negative pin, which I would run a wire from the negative to the bottom. I like to use the bottom rows as my negative. Then we have the positive, which I would run a positive wire from this terminal up to the top rows, which I like to call the positive. These terminals will plug in, a little plug in here and in here, straight into our bench supply in here, and down into here and here. Okay, just so that we can see how the components actually fit in, let's just place a few components in. What have we got? So I can go from this line here to this line here. We just place them in. The legs are a little bit long at the moment, so they do become a little bit difficult to put in, but as you can see, they fit beautifully in. Now I could make this into an RC circuit, a resistor capacitor circuit. So I've gone from, to take him from there to there. So I've gone from there to there, and then I put a line in from my positive supply down to the capacitor via a resistor. Can you see that? Yep. Can't quite see it. Resistor, okay, from positive here, from positive here down to the joining track, my capacitor, and then from my capacitor I would put one from here down to my zero line at the bottom of the breadboard, down here. But as you can see, the main point of this is just to show you that the components plug in and out nice and easy. It's a very, very handy gadget, breadboard. Very, very handy. Capacitor comes out nice and easy. Okay, fantastic piece of equipment. That's a breadboard. So, that is how to use a breadboard. Okay, little Madison, 5-year-old little Madison. She's out in the backyard. She's filling in this rather large hole. Anyway, she's a bit upset little Maddie, and she's filling the dirt in, bit of a tear and a cry here and there. Anyway, Mick, the neighbour, he hears this going on, and he pops his head over the fence and he says, "Hey Maddie, what are you doing, love? Why are you upset?" And she says, "Well, my goldfish just died and I'm burying him." And Mick says, "Oh love, there's no need to get so upset. These things happen." And he says, "But that's a mighty big hole for a little goldfish." She turns around and, yeah, it is. But he's inside your cat."